Welcome! In this video, we are going to take a look at problem 10. It is from chapter 5 of College Physics 2E by Openstax. In this problem, we have to find the deceleration of a snowboarder that's going up a 5-degree slope, and we are going to assume the coefficient of friction for waxed wood on wet snow. Let's take a look at table 5.1. And we see for waxed wood on wet snow, mu k is 0.1. The snowboarder is moving, so we want the coefficient of kinetic friction. All right, let's write down what we know. Okay, we know the mu k is 0.1, and let's call theta is 5 degrees. Okay, let's make a triangle. Make it pretty big here. Here's our theta. Let's put the snowboarder, say, there. And we will use a coordinate system with positive x going up the slope, positive y perpendicular to the slope. Okay, the force is on the snowboarder. Snowboarder's in contact, so normal force perpendicular to the slope. Movement is up the slope, so friction is down the slope. And then there is a weight that is straight down. Okay. If we draw the perpendiculars, then this will be the y component. This will be the x component. And by geometry, this will be the theta up here. We can extend this to make a right triangle, and then this angle here is 90 minus theta, and so that's why theta is where it is in the small triangle. Okay, let's find the components of weight. If we take the sine of theta, we get the opposite, wx over hypotenuse w. So the x component is w sine theta. If we look at the cosine of theta, we get the adjacent side, which is wy, over the hypotenuse w. So the y component of weight is w cosine theta. Okay, so we have our components. Now we can look at Newton's second laws. We can apply Newton's second law. So summing the forces in the x direction will be equal to the mass of the snowboarder, which we don't have, times the x component of acceleration. Generally, in a problem like this, if we don't have something, we don't need it. We can either find it in a table or we don't need it. All right, so in the x direction, we have friction downslope, so that's a minus f sub k. And we also have the x component of weight downslope, so that's a minus w sub x. They equal ma sub x. Okay, we can put in for the wx, and that is going to be minus w sine theta. Okay, we can sum our forces in the y direction. There isn't going to be any movement in the vertical for him on the slope, so this is going to be 0. And there we have a positive normal force, and we're going to subtract the y component of weight, which would be pointing down. So we find our normal force is equal to the y component of weight. And so the normal force is w cosine theta. And we can substitute for w. So we get mg cosine theta. We'll go back and do that for the x equation as well. But let's look at the definition of kinetic friction. It is mu k times n. So we can put in mu k times mg cosine theta. All right, so now let's substitute for the Fk and we'll substitute for the W as well. So I'll put it down here because it's going to be long. So for Fk, we have mu k mg cosine theta minus W is mg, that is times sine theta, that's equal to ma sub x. Okay, every term has an m, so we can cancel it. We've got one here, here, and here. All right, that's good. And so we end up with a sub x, right, is minus mu k. We've got a g cosine theta minus g sine theta. All right, we can factor out the minus g. We're left with mu k cosine theta plus sine theta. That isn't absolutely necessary. We could have just substituted, but so we've got minus g itself is 9.8 meters per second squared. Mu k we saw was 0.1. Then we have the cosine of 5 degrees plus the sine of 5 degrees. Okay, I did that calculation and I found a sub x is minus 1.83 meters per second squared. And then we can say a is equal to a sub x since the a sub y is 0. Now, technically speaking, we were looking for deceleration. And so we would say a is just 1.83 meters per second squared. The word deceleration implies the minus sign. Okay, so either way, it will be fine. All right, I hope you found this helpful. Let me know if you have any comments or suggestions or questions, or if there's any other problems you'd like to see me solve. I'd be certainly happy to do those. Thank you for watching. Please like and subscribe, and I'll see you in the next one.